Welcome to this interactive study breakdown on Further Algebra and Functions, a cornerstone of the WJEC A-Level Further Mathematics specification. In this guide, we will explore the deep connections between polynomial roots and coefficients, powerful series summation techniques like the method of differences, decomposing fractions with irreducible quadratic factors, Maclaurin series expansions and their radius of convergence, and the logical rigor of proof by induction. These topics frequently appear in multi-stage exam questions, so mastering them is essential for securing top marks. Let's dive in. Let's map the key concepts. At the center is the idea of algebraic manipulation of expressions involving roots, series, and functions. Vieta's formulas connect coefficients to symmetric sums of roots. Series summation often uses the method of differences, where terms cancel telescopically. Partial fractions extend to irreducible quadratics, demanding a linear numerator. Maclaurin series provide polynomial approximations, valid only within a certain radius. Finally, proof by induction gives a rigorous way to verify statements for all natural numbers. Turning to our core study notes, Vieta's formulas are essential for relating root properties to coefficients without solving the polynomial. For a cubic, the sum of the roots is negative coefficient of x squared divided by leading coefficient. The sum of pairwise products is the coefficient of x divided by a. The product is negative constant term divided by a. Remember the alternating sign pattern, this is a frequent source of exam mistakes. Using these, you can find expressions like squared by squaring the sum and subtracting twice the sum of products. Now we walk through the method of differences, a powerful technique for summing series. The idea is to express the term u_r as a difference of consecutive terms of another sequence. For example, to sum r from 1 to n, we use r equals r plus 1, r01, r2. When you sum from r equals 1 to n, most terms cancel, leaving a simple expression. This method works for many series, especially those involving products or rational functions. In exam questions, you'll often be given the general term in sigma notation and asked to find its sum. Let's work through a typical exam question, finding a polynomial whose roots are squares of the original roots. First, extract Vieta's sums from the given cubic. Then compute the sum of squares using the identity. Next, compute sum of squares in pairs and product of squares. Finally, assemble the new polynomial using the pattern with alternating signs. This method works for any symmetric transformation of the roots. Watch out for these common mistakes. First, when applying Vieta's formulas, the signs alternate starting with minus for the sum of roots. A slip here can cost all marks. For partial fractions, if the denominator contains an irreducible quadratic like x squared plus 1, the numerator must be linear, not just a constant. For Maclaurin series, always state the range of x for which the series converges, often found using the ratio test. In induction, never skip the explicit statement of the inductive hypothesis, and ensure the inductive step clearly uses that assumption. To wrap up, memorize Vieta's formulas for cubic equations, grasp the telescoping cancellation in method of differences, handle irreducible quadratics with the correct numerator form, know that Maclaurin series converge within a radius, and master the logical structure of induction. These tools will help you tackle even the most complex problems in your exam. Good luck and keep practicing.